Welcome to Knowledge Share channel. In this video we will be discussing about analog to digital converters. In previous video we discussed about digital to analog converters. In this video we will be discussing about analog to digital converters. In short it is called as ADC, that is analog to digital converter, ADC. So what is the function of this analog to digital converter? It converts analog signal to a digital signal. Yes, you all know the signals are of two types. One is the analog signal, the other one is the digital signal. For example, the digital signals can be understood only by the digital systems like computers and cell phones and other things, whereas analog signals can be recognized by means of sensors. So whereas the sensors, if we give the digital input, it will not be able to recognize. So some of the electrical appliances will be accessible only by the analog signal, whereas computers, pagers, cell phones and other things will be operating by the digital signal. So we have two different types of signal. So we need to convert in many cases the analog form to digital form in order to make the sensors to understand the data, or in order to make the digital system to understand the data. Okay, so this is the main application of the analog to digital converters, which is going to convert an analog signal which is given to it in a digital format, and which can be read by the computers and cell phones and other digital appliances. So as you all know, so this analog to digital converter, what it does is it is going to get the analog input and it is going to convert it into the output binary data. So output binary data is nothing but it will be having D1, D2 up to Dn. So the form is nothing but D1 2 power minus 1 plus D2 2 power minus 2 plus up to Dn 2 power minus n. So here you can see that. So this is the block diagram of the analog to digital converter. So the analog input is given to the ADC. Okay, the analog input is given to the ADC, and it is having two different signals. One is called the start signal, the other one is called as that is end of conversion signal. Okay, so that is, in short, it is called as EOC, and the output is nothing but D1, D2 up to Dn. So how many number of binary digits we need? So those things can be decided by the designer. So the final thing is the analog input is given to the ADC, and it is going to convert into the binary output, that is D1, D2. So D1 can be either 0 or 1, and similarly D2 can be either 0 or 1. So this analog input is going to convert it to actually ones and zeros of the output. So this is called as the analog to digital converter. So this is the block diagram. So it will be having a start command, so that in order to convert, in order to make the conversion starting, the start command has to be given, and after the completion of the conversion, the ADC will be giving the EOC signal, so that informing that the analog input has been converted to digital output. So this is the block diagram of the ADC. Okay. So moving on, there are two different, any ADC can be classified into major classification. It is having direct type, the other one is indirect type. So two different types are the direct type and indirect type. So similarly, in direct type we are having four different types. One is called the flash type converter. The second one is staircase type converter. The third one is tracking converter, and the last one is fourth one is successive approximation type converter. And in case of indirect type, it is classified into two different. One is called the charge balancing analog to digital converter, dual slope analog to digital converter. So each and every type is having its own plus and minus, and based on the for example, our application, we have to choose which particular ADC will be suitable for our application. We have to choose correctly. So only by knowing its plus and minus, we will be able to identify which particular type of analog to digital converter will be suitable for our particular application. So in this we will be discussing about successive approximation type ADC. So okay, so in this we will be discussing about successive approximation type ADC. So this is the block diagram. So again here you will be having an here you can see that it consists of a SAR. So SAR is there, which is nothing but a successive approximation register is there, and it is having one OPAMP is there, and one DAC. So that is a digital to analog converter is there. So this is the building block of the ADC actually. So it is having three different elements. One is the SAR, the other one is the OPAMP, then third one is the DAC. So only if you have all these three, we can we can connect accordingly, and we can build this successive approximation type ADC. So then what is the use of, so you know what is DAC. So DAC is nothing but it will be converting the digital signal to analog signal. So here you are having a comparator. So this whatever the digital output is there, the digital output will be converted, that is the analog output will be converted to that is the digital output will be converted to analog, and this analog input is fed to the OPAMP, because OPAMP can only read the analog signals. Okay, and it will be comparing it. Okay, and this is how it functions. So what is the use of SAR, that is the successive approximation register, is nothing but it will be used to find each and every bit by trial and error method, and it will be comparing the, for example, it will be comparing actually the input with the DAC output, and only when that input is exceeding, it will give an end signal, and because of this the successive approximation type will be able to give a correct analog to digital conversion output. Okay, so let's go on how it works. Okay, let's see in detail. So for example, in this, if the start command is given, then the SAR sets its MSB D1 to 1. So here this D1 will be set to 1. So this will be set to 1. And when all other bits are set to 0, the other all, for example, D1 is set to 1, the D2, D3 up to Dn will be set to 0. And because of which you can see that it will be having a trial code. So the trial code will be nothing but 1000 and 4 zeros. So the output VD from the DAC is now compared to the analog VA. So the analog input is given to the op-amp, and this VD output. So this is going to convert this from the shift register, this digital to analog form, and it will be given to the op-amp, and both will be compared. Okay, and if VA is greater than VD, then you can see that 100040 is less than the correct digital representation. So now what we have to do is, again the MSB remains at 1, and the next bit is made 1 by SAR. So again what it will do is, it will again make the D2 as 1. So D2 will be made as 1. So now the trial code, now it will be 1100 and 40. So suppose in this case, if VA is less than VD, if VA is less than VD, so it is going to compare, this op-amp is going to compare, if VA is less than VD, then SAR resets the MSB bit to 0. Then what it will do is, it will reset this MSB most significant bit to 0 and go on to the next LSB. Okay, it will move on to the next, that is D3. Okay, it will move on to the next D3, and since 1100 and 40 is greater than the applied digital input. Okay, so this procedure will be repeated with all the subsequent bits from MSB to LSB. So from MSB to LSB, it will be comparing, and finally at one time, until all the bit positions have been tested. Okay, then and when the DAC output crosses the analog input, then the comparator will be changing the state, and it will give a end of conversion command. So this will be giving an end of conversion command, and from this the data now available in SAR. So the whatever data that is available in SAR will be the digital equivalent. Okay, will be the digital equivalent of the analog input. So this is how the successive approximation type ADC works. Okay, so the main advantage of the successive approximation type ADC is nothing but it will be having high resolution is there, and because we are having more number of bits, as well as it is more versatile, and it is also very it can operate at very high speed. So this is the main advantage of the successive approximation type ADC. And so in this video we have discussed about the ADC and its what are the broad classifications, that is direct and indirect, and in that case we have discussed about only one type, that is successive approximation type. And I'm sure the block diagrams and other explanations, everything is clear to you. And if you really like this video, please give a like to this video, and if you have anything to share, please comment in the below comment section. And as well as if you feel that this video will be useful to someone, and please share this video. And if you really like this like the content which I post in this channel, please subscribe to my channel. So thank you very much for your patient listening. Thank you.